go. There we go. Hey there, welcome everybody once again to Astronomy Daily Live. Wow, almost a minute late. Wow, I gotta hang my head in shame. We were having some good conversation in the pre-show here, and just got completely carried away. So yeah, I hope everybody's doing well. Uncle Bill, I see you in the chat. Nice to see you over there. Excellent, excellent. Nice to have everybody in. So come on in, everybody. Let's gather together as we do pretty much every day and think and talk all things astronomy and space and science and other kinds of nerdy things. Like to focus, on mostly astronomical things, but hey, this is a gathering of friends, so we can go off pretty much anywhere that we want. Atta, hey there, nice to see you in the chat as well. Great to have you here. Fantastic. So cheers. So grab your favorite consumable of choice. I've got the hydrogen hydroxide again tonight, the HOH. So cheers. So yeah, I hope everybody's doing well. So yeah, overnight, last night here we did get some snow, and it was actually quite a bit. It was quite a bit once again, and woke up to a winter wonderland here in southeastern Arizona, and it's a thing that I definitely do not like to see. Right, when I look outside of the window, right, I want to see a desert landscape, right? I don't necessarily want to see a winter landscape, but the really nice thing about it here is that the sky cleared up, and the sun was out most of the day, and most of that nasty stuff was gone by noon or so. So that was a relief. That was a relief. But for a while there, all the snow that had fallen on the roof, right, melted really fast. So I mean, it was like we were in the middle of a rainstorm, with all the melt off the roof. So hey there, Chuck, nice to see you there. And 9-inch Colas, hey, nice to see you again there in the chat. Excellent. Glad you could stop by. So yeah, that was nice. It was also nice to see it gone. And so, well, before I proceed too far, I want to say howdy to my panelists. So hey there, Bobby, what's going on over there?
All right. Hey, did you look at Altolano's message about having a Star Trek session and something like that? And probably would say Sky should just suck it.
Yeah, I'm going to ask her about that. Yeah, I definitely want to know a little bit more about that. So
well, whatever you say, I wouldn't take off Sky Alias yet.
Yeah. All right. Well, good. Excellent. Glad things are well over there. And Tom is on the panel again. Hey there, Tom.
Hey, Cosmic. Hey, everybody. Hope all are well tonight.
Everything's good. Just you.
Yeah, like I said, I'm not sure if an idiot lady from Pennsylvania, I don't know where Sky Alias is from, but I'm not sure if an 80-year-old lady can punch the crap out of Sky Alias's nose.
Yeah, so Atta, you had a successful Star Trek event. And yeah, I want to find out a little bit more about that. I'm not I don't know what that means. That has a certain connotation to a certain television show and some movies that I know, but maybe this is something else. So yeah, if you want to describe that a little bit more, it sounds kind of interesting. Was it sort of coincidental with the full moon? Is that what this was all about? Don't know. And yeah, I actually haven't been over to Skylius's stream over on Twitch in quite a while.
Me neither.
Yeah,
I better go on Twitch.
Yeah, I go on to Twitch as often as I can. I'm much more of a listener of these live streams, that I am, like a participant or a watcher, because I'm usually here working on things, working on code, or working on, reading things, and it's kind of hard, to read things and listen to things at the same time. So yeah. But she is doing an excellent job. Casting a very wide net, to capture the interest of lots of different kinds of people. And the one thing I can say, and I can say a lot of things about her, a lot of good things about her. But one of the things that I like about her, and the group that she sort of grabs, is that they really seem to be having a great time. And
Yeah.
I think that is the most important thing, right?
Especially when she goes like on those YouTube videos and look up documentaries and stuff that are open base.
Yeah, that's a great jumping off platform, right? Yeah, that's a great way, to sort of get into topics, and then dive into them a little bit more, and talk about them more. We sort of do exactly the same thing here, except the platform that I like to use is more of the scientific journals, those kinds of things. But
okay.
It's basically exactly the same
So
thing.
at the water, we just had general public observation throughout scopes and hers, but all the Skype was sketching Cytor T, wherever that is, Star Trek uniforms. Okay.
Star Trek uniforms.
And went
Very
to
cool.
welcome Ron from Earth Radio. All right.
Hey there, Earth Radio. Nice to see you in the chat again. All right, so that's kind of cool. So you were dressed up in Star Trek uniforms, doing your normal telescope thing. Well, very cool. Very cool. I think Atta, you have an evolution, right? A Celestron evolution. Is that right? Because if so, you might want to.
These E-bands are bringing a lot of money for the observatory. That has got to be like bad to the bone.
Well, that's cool. Yeah, if one of the goals
Next
of
star evolution.
Yeah. Okay. So that is.
If anybody does not know Ron from Earth Radio, I just posted a link of where you and the link is incorrect, so let me correct it.
It is incorrect. Man, you deserve a slap on the hand there, Bobby. Man, look at that. Nasty. So yeah, ERT I think has this pretty much the same scope that ATA has. So so cool. Cool. Very, very cool. There we go. So there's a valid link there. So yeah. Very, very cool. So yeah, check out Ron's radio channel. Plays lots of music.
He plays some good music at his afternoon show. Some like elevator style new age or something like that.
Yeah, sweet. Good, good, good. And I know I think one night a week, like Sunday nights or something, they have some kind of a heavy metal show, and I think Johnny Unitas, I think he does some kind of a show. I'm not exactly sure. I haven't listened to that one yet. So and okay, Friday at midnight. Sorry. But yeah, usually the conversations over there are pretty good. Sometimes they can go off the wall, which I mean that's life, right? So yeah, definitely check out ERT Radio over there. I'm just looking at the kitty in the lap here. She's decided in the past couple of weeks that
it's a producer Bill on KGRA right now, Ron.
Yeah, I think he does the Friday heavy metal thing. I think so.
And it's internet radio only KGRA. I usually thought it would be like some type of AM, FM, or some type of shortwave station, but no, it's a digital internet radio station.
Oh, cool. Very, very cool. Anyway, so...
But it's a good listen to, though.
Definitely. Definitely. I definitely need to check out more of KGRA. I know that Mark D'Antonio and I forget the lady's name. Anyway, Amanda. Yes, of course. They do a sort of a space-related show on Sundays. Don't remember exactly when that is. What I do is I just go over and grab the MP3, and then I throw it on the smartphone. I listen to it in the car, when I'm driving to work and stuff.
If I'm not mistaken, I actually am now friends. Even though I don't think he posts that very much, I don't think he was active or something. The general manager for KGRA friended me on Facebook by surprise. So I was like, okay, I'll take it.
That's cool. That's cool. I think that's also Bill, right? Is that true? I don't know.
I forgot the name. I forgot his name.
Yeah. I don't know. There are way too many names out there. I can't. It's hard enough to keep track of my own. So yeah. All right. Well, cool. Well,
I know I belong to many of those Latter-day singles pages for Latter-day Saints, and then every once in a while, if there's like a beautiful lady about my age, I just say hello, and it's a darn she said anything back or not. So
there you go. Well, you've got to be friendly on those kinds of things. So, and you never know, right? You never know. So yeah. You got to definitely have to reach out and try those kinds of things. So cool. All right, excellent. And so just really briefly. Um, 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 if you didn't see the invite to my new Discord server, I started one up, trying to gain some momentum and or traction on this lunar observatory project of mine, I guess you can say. I mean, I'm not going to call it mine. And that is, to put a telescope on the moon, at least one, maybe even more, right? I don't know, but I, the sort of brief conversation that I had with John McGraw, who wrote a similar proposal back in the early 90s. What he said many times is that you have to make the science case, right? You have to come up with some things that can sort of uniquely be done on the moon, as opposed to in space, right? So that's I mean, there are a lot of things to focus on with this kind of a project, right? You have to think about what kind of instrumentation, what kind of telescope, what size of telescope, what the structure is going to be like, what kind of lander is it going to be, what kind of launch vehicle are you going to use? Are you going to be a primary payload, a secondary payload? And then, of course, you got to worry about costs, all of that. There's lots of considerations, but what makes a lunar-based observatory better than just some observatory in low Earth orbit or at one of the Lagrange points? What makes it so much better, right? And so that is at least one of the big questions to think about and to talk about. And so I started a new Discord server where I want to start having these kinds of conversations, because I've got at least in my own head, right, in my own crazy head, right, I've got a really short timeline, right? One of the things that is very much compelling me to want to put something on the moon, right, is to view a lunar eclipse from the moon, which I think is I mean, that would really look epic, right? I think that's a $1 million shot, right? Easy, right? I think there'd be a lot of interest in that, and I think it would look absolutely fantastic. And so well, lunar eclipses, they happen a couple times a year, right? So, okay, what's the rush, right? Let's get something up there, when we can, right? Well, there is a little bit of a rush, because the lunar eclipse that is going to be happening on May 26th of 2021, okay, as viewed from the moon puts the sun and the Earth right in between the Pleiades and on the Hyades, like right in between them, right? And I think that would be a spectacular view. Now, there's a little bit of question in terms of, could you actually see, the Earth, passing in front of the sun and these background stars? I don't know, because a solar eclipse from the moon is still going to be pretty bright, right? Pretty bright, but we know from observing solar eclipses from Earth, right, that we can see some of the brighter stars. And so I think we should actually be able to perform some kind of calculations, right? To figure that out, and to sort of set the parameters, the exposure times and all of that, to be able to see that. So I think it's possible, but we really have to work that out. And this lunar eclipse viewer would probably be a separate telescope and camera, some kind of a refractor, relatively wide field. It might even be like a fisheye lens, right? A really wide field thing. I don't know, but I think that would be an epic view, but that puts this whole project on an extremely fast timeline, right? That's like 29 months from now, right? So, is that realistic? Is that possible? Honestly, I don't know. And one of the things that I mentioned to John McGraw is that as opposed to back in the early 1990s, when he wrote his thing, we now know that all these things are possible, right? We know how to put telescopes out into space, right? We know how to actually land instrumentation and telescopes on the moon, right? The Chinese have done this. That telescope, that Chinese telescope, has been running for the past 4 years, right? So that's not an incredibly long time, but it's still going, right? So we're not going to have to necessarily invent anything new or sort of hope that this works. Everything that needs to be done has already been done. It's just sort of, it's just almost a matter of just, putting all the pieces together and doing it, right? And what I've observed is that all that really takes is the will to do it, right? It doesn't, if this, had never been done before, or if we weren't quite sure how to land these kinds of things on the moon, all of that, then I'd be like, okay, 29 months is probably not really a realistic thing. But if all the pieces are together, right, or they exist already, and we just have to have the will to do it, then that makes it, at least possible, right? To get something up there in the next 29 months. I don't know. I mean, that seems really, really fast.
If they would have the stuff to will get it done in less than 29 months, would they be able to do it?
Well, like I said, I mean, all the knowledge and experience is already there to do it. It's just a matter of doing it, right? There's nothing new here at all.
But Yoda would say, do it. Do or do not. There's no such thing as try.
Yeah. But, I mean, but there are a lot of details, right? There's a lot of details to work through because, I mean, a launch provider, right? They need to know how big is it, how much does it weigh, and where's it going, right? So, we have to be able to answer those kinds of questions. A lander, right, needs to know where's it going, what kind of thrust do I need, to land this thing? What kind of moving around do I have to do? You have to decide on the size of the telescope, right? And the size of the telescope is going to dictate what kind of structure is needed. All of that. So yeah, there are a lot of details that have to be worked out, and things have to be physically built, right? So we need the will to do it, and we need the personnel to actually, build this stuff, right? You're not necessarily going to go to Celestron, to the Celestron dealer down the road and buy yourself a telescope and launch it, right? There's thermal control things, that have to be dealt with, and all the electronics, all the communication, all the radio stuff, all of that. There's lots of details, right? But all this is being done, right? The Lunar Reconnaissance spacecraft, right, is sending data to us from the moon right now, right? So that's being done, right? We know how. So I don't think that there is, I don't think that there's anything new, that has to be invented or experimented with and modeled and everything else. No, I think it's just a matter of, like I said, putting the pieces together and doing it. People who know much more than I are hopefully going, to tell me things like, well, it's not that easy, right? And I mean, I'm not saying it's easy, but I think it is just a matter of wanting to do it and finding the people to do it. Anyway, I don't want to burden this live stream with that. I'm thinking that we'll definitely have some conversation over on the Discord channel. Maybe have some live audio things there, either there or like on Skype or something. But yeah, I think it's sort of what I'm sort of interested in see is trying to stir up some interest and get some traction. Just to see if we can make this goal of getting everything up there and running by May of 2021. Because yeah, I want to see that eclipse. I think that would be epic, right? So yeah, and also, you know, put up this really great telescope that can um, um, deliver some really interesting science. Right. The only science case that I have thought of that is sort of unique to the moon is this long duration exposure type of thing. Right. You can sit on a target for, you know, up to 14 days, right? Which you can't do here at all. So you know, that offers, I think, some interesting opportunities. I'm hoping that there are some other unique science cases. But so far, that is the only one, you know, that I've come up with, and
I wish I had like a big company like that will come up with a conceptual design of either having geostationary satellites that allows broadcast to use those satellites, and it is receivable below 1 gigahertz, like above 30 megahertz to below 1 gigahertz and stuff, and allocate some space where you can just use your regular antenna, your regular receiver, and bam, you're getting a broadcast station from a satellite with your intent without needing any extra equipment like a dish or something like that.
cool.
But
Yeah.
geostationary could be one thing. Having a series of polar low Earth orbiting or equatorial low Earth orbiting satellites, I think that's another good example, because I think, like, if you do low Earth, I think it's usually quite okay to do it a geostationary, because because I think you might have to go higher than 1 gigahertz, maybe higher than 2 if you do geostationary, and that's something that you don't want. You want to work with below, like above 30 megahertz to below 1 gigahertz.
Cool.
I think
Very
that would be
cool.
a good idea.
Yeah, neat. And yeah, I totally agree that you know, the Chinese might be the ones leading the way in terms of space and all that. But you know,
There's the Russians.
yeah, you know, as I said though, I'm wishing, hoping that we can start working together, right? Because I don't necessarily think that it's the Chinese that are saying we don't want the Americans here, right? I actually think it's the other way around, right? It's the Americans saying we don't want to work with them, right? And oh, come on, really? So you know, because the Chinese are working with the Europeans, right? The Europeans have a couple of instruments on, you know, the Chinese lander on the far side right now, right? So that's why it's sort of, I'm not sure if it's, you know, whether it's the Chinese, you know, that are saying we don't want the Americans, or
Or it's like Trump, like, wants to do like the all American thing and screw like trading through other nations and stuff.
yeah, well, you know, I mean, I have no problem
Or
with
what Great
that, but
Pearls you likes to call him, the Tangerine Spinter.
well, you know, I mean, when you have countries, right, they're going to have, you know, lots of different things to do, and you know, they can sort of decide at that level whether they want, you know, to work together or not, right?
I think if we can come as one, like Otto Lada would say, and come up with a nice conceptual design, I think that would be better than best.
yeah. Well, and like I said, you know, the Europeans, the European Space Agency has instruments on the Chinese lander that is currently on the far side, right? So, the Chinese don't seem to be against cooperation, right? So, so I don't know who's saying no, right? And maybe it's both sides, that are saying no. But yeah, the Chinese are going to do their thing, and I think they should, right? But there are a lot of launch providers now. There's a lot of companies that are working towards developing space a lot more, and that's
Do
actually
you
one of my
think
arguments.
the rest of the world should hire a Cuban scientist or something like that? Because usually when you listen to Radio Havana, Cuba, they always got some good ways and means about how great Cuban science and Cuban technology usually is. They're pretty popular with that.
I think that we should encourage all good ideas, right? Don't close your ears off because of some label, right? So
Right.
yeah.
And you're supposed to. I cannot believe we have labeling today.
Oh
And
yeah.
we should not have labels. We should not be like some kind of meat puppet or something.
Yeah. I totally agree, especially when it comes to, scientific endeavors and exploration and all that. I mean, it is definitely, I mean, we've always been explorers, right? And space is just the new frontier, right? And it's really no different than things that have happened in the past. It's just sort of a different place, right? But the same kinds of challenges. It's really expensive. There are some harsh realities that you're going to have to deal with in some way. So yeah. I mean, in terms of ideas and stuff, yeah, if anybody has a good idea, I definitely want to hear about it. So yeah, absolutely.
That's
So
it.
yeah,
So the search for truth has no color, no religion, no sex, no nationality. That's correct.
yeah, I think that's about right. Yeah. So anyway, I'm not going to belabor this much here in this live stream. I don't think that that's the appropriate place to do that. But I'm definitely looking for some interest and some traction.
And I don't think you. Well, since we're pretty much moving along, Ron from Art Radio had a question, and I'm sure if you have any experience with those types of cameras on newer telescope, what's the best way to use a DSLR on a Celestron? About it,
Yeah,
you
that
have an
is.
answer.
Yeah, I don't, Ron. I don't really have enough experience with those kinds of things to really be able to help much. Um, like I've said several times, at least there are a lot of online resources to probably answer that question pretty quickly, right? But yeah, specifically, yeah, I'm probably the wrong guy to ask on that.
Would Cloudy Nights will be a start for Ron?
Cloudy Nights is an excellent resource. Excellent. In fact, I think they probably have a DSLR section. So yeah, like I've said a couple of times, and I will say it again, get over to Cloudy Nights, because they that community knows their stuff. They're also very enthusiastic, very very friendly, and extremely helpful. So yeah, I would say get over there, check out their forum. As I said, I think they have a DSLR section, where you can feel free to ask anything, right? And in fact, you go through the lists of all the postings, right? And you may actually find that the question you have has been asked hundreds of times before, right? OPT is great. OPT is great. Yeah, they are absolutely flooding the market. So yeah, good on them for sure. OPT definitely isn't the only source, right? But they seem to be a pretty good source. So yeah, cool. And they've got tech support, so that's kind of cool. That's pretty cool. All right, cheers to tech support. Yeah.
Yeah, I'll take it.
So yeah, as I said,
I think Tom wanted to say something.
Go for it, Tom.
Well, I was going to wait until you were done, but just a note, this day in space, Nicholas Copernicus was born in 1473.
Wow. Yeah. So many things during the Renaissance was sort of redug up, right? And the concept of a sun-centered solar system was he definitely wasn't the first, but he revitalized all of that right at the right time, So
Well, and not only that, he was a mathematician, so he did a lot of the math for it, and he wrote a book, describing the model. And
yes, yeah. In fact, one of my early jobs. Here's a story time. One of my early jobs at the University of Arizona was working in a section of the library that was called Special Collections, and Special Collections, as the name implies, was a part of the library that had collections of letters and correspondence and reports and books, right? And back in the vault, right? And I'm sure the vault is still there. I don't know if I should be talking about the vault, but I'm going to talk about it anyway. Back in the vault, right? They had several extremely interesting books to a young astronomer, right? One of the books they had was I don't remember it. It wasn't a first edition. It was a second or third edition of Newton's Principia, right? So I think from I want to say from around 16 something or so. So I held in my hand a very, very old version of Newton's famous book.
Of my curiosity when it comes to astronomers and scientists and stuff like that, were there any like African American or Black astronomers or anything that regards to space, or what do you think?
There has definitely been a suppression of lots of information in terms of both black and female scientists, right? And I'm extremely guilty of not knowing more more about those. Um, but
Yeah, yeah, I think that's the saddest thing about schools and stuff. They're always like more have that ratio or like in like masculine. No, there's no feminism and stuff like that. So it's always like just the men, and no women, no race or anything. If there was ever is going to be a time where you have to like tell them, hey, we need to do something about it, because there's a thing on. I was watching the Y on Newsy, and they got some people that eventually flunked out when it comes to testing out if you know Black history. And that's sad if you don't know Black history because you never was taught Black history.
yeah. No, I think many of us, me included, um, for sure have been left out of a lot of extremely useful pieces of information, right? And I know for an absolute fact that women in science have definitely been, used, but not really highlighted, right?
That, and that's the sad thing about it. Even when broad spectrum radio was on WRMI, he was a good voice commentator, but he was a bad radiogrammer. But he was talking about the Green Corn Rebellion that pretty much like protested the World War I drafting or something like that. It's something like that. Either World War I or World War II. I forgot what it was. And he also said that it is being ridiculed, mocked, or not mentioned in American history.
Yeah. Well, there's most of the time, history is well, hate to use the term, but I mean it's pretty ugly, right? I mean what we're taught is sort of really, really, really gentle, right? When in truth it's been pretty harsh, and it's been especially harsh on women and minorities for sure, right? And um, the lesson I learned from that is let's start including all of those. It's ridiculous not to, right? I mean, it's like chopping off your arm, right? I mean, why would you want to chop off your arm, to get a job done? I mean, we need both arms.
I cannot believe we were taught like supremacist ways and means instead of like waking up and smelling the roses and like I said, is like maybe we should eventually, if we can change the education system to include Black history, to include women history, and all that, then you're talking about smart people when they do graduate, and maybe it will definitely will help improve their scores in standardized testing.
I think, I mean, what I realized long ago, right, is that if I change my own thinking about things, right, then really the rest of the world will also change, right? So if you change how you think and behave about things, then everything else will too, right? Now that is going to take some time, right? But um, I decided long ago that yeah, I'm going to include everyone I can possibly think of, right? And I don't care uh, what they look like, where they come from, right? I mean, as long as they're behaving in sort of a nice way, right? I don't care what they look like. I mean, come on, that's ridiculous, right? So I would recommend starting there, because then everything that needs to change will change. So change automatically, right? Because the
Yeah.
attitude will change.
Yeah, and that's why I said, and that little statistics, they may be smart of basic or regular American history when it comes to like standard social studies, like civics and stuff. But when it comes to like learning Black history and stuff, that's when the number drops.
Yeah, yeah, and yeah. I mean, I think that being aware of all these things, I think that actually makes us better, right? I mean, instead of being ignorant of things, we should know as much as we possibly can, right? And it's okay if it's ugly, right? I mean, that's part of life, right? Lots of life is just ugly goo, right? And but that is definitely part of it. So
And to be honest with you, when speaking of when I recall my American history textbook, there was like some form factor of like Black history. There is some form factor of like female history and stuff like that. I mean, it can be in the details, but it's just something that you gotta look at.
yeah, it's just I mean that information has very much been suppressed, right? And like I said, that's sort of like chopping off your arm, right? It's like, well, you'll survive okay, and you'll probably do all right, but it's like, I would much rather have my arm attached and functional, right? That makes life better, right? So let's include everybody, right? I mean, that to me is sort of a no-brainer, right? And to suppress all of that, I don't know. That's just not very intelligent. So yeah. All right. Well, cool. Let's do a quick dive into the constellation of Leo, because we're still in Leo. In fact, we barely even scratched the surface with Leo. So I wanted to get back over there and at least look at one more thing before we have to end it for today. So let's see. All right. Well, I'm over there, so I'm gonna share my screen really quick. Like that. Oh, gotta press the right button.
Oh, I hope you didn't take us off the air.
No, no, no. I'm only gonna do that once. Maybe. Let's see. So where are we here? So here's Leo. So let's see. We looked at Regulus and we looked at Beta the other day. Here's Gamma Leonis. Some it's kind of strangely said here, right? It's a binary star with a third optical component. So I guess that means that there's three stars involved in that guy. Okay. There's Delta Leonis, otherwise called Zosma. That's kind of an interesting name. Doesn't say much about that star at all. I wonder if there's anything interesting about Delta Leo that we don't know. Let's find out. Basic search. Delta Leonis.
To be honest, man, you're getting me want to like put my Stellarium back on my computer.
Well, there you go. Nothing wrong with that. I don't know why you took it off.
I redid my system by mistake.
Ah, I see. See, well, here's a good excuse to get it back on there. See? So yeah, he's moving pretty fast. Pretty fast. Let's see, what kind of a star is this? Okay, so it's also an A star, an A5. I think Beta Leonis they called an A3. So this is similar. Pretty bright. Obviously visible. So that's pretty cool. I forget which one this is now. Delta Leonis. So that's this guy. Delta. This guy right there. So here's Alpha, right? Regulus, the bright one. Beta is the tail, and Delta is just up from Beta. So you should be able to see that. Also, even in a pretty bright sky, you should be able to see that, I would think. So that's kind of cool. Let's see, anything really interesting here? Looks like it's moving towards us at about almost 21 kilometers per second. So that's moving a little fast. I mean, in terms of stars, that's relatively fast.
That usually doesn't mean it's going to hit us, huh?
Well, probably not. Probably not. See, because it's.
I mean, like Carl Sagan can can remember a neutron star, but a high approaching motion star. Dude, I think we're gonna get burned.
Yeah, well, I mean, what this means, right? This first number means that it's moving that fast in right ascension, right? So basically right and left, right? And then it's moving this fast in declination, basically north and south, right? And then radially, right, either coming towards us or going away from us, it's moving like that. So yeah, you sort of have to think of this in terms of 3D, right? So here's sort of your direction in X, right, left and right. Here's your direction in north and south, and here is your direction in and out, right? So if you sort of make that sort of a 3D thing, you'll notice that the star probably is extremely unlikely to run into us. It's going a different way, right? It's going a completely different way.
Good.
So, yeah, well, yeah, we sort of, get a little bit nervous if there's a star that's going to run into ours. That would make for sort of a bad day. So we don't really want that to happen. And in fact, we we don't really see that happening very much. Stars running into one another. At least no direct evidence of that, right? Yeah, I have to look into that a little bit. But I think that's a relatively rare thing to actually happen, even inside of clusters. I just, and that's actually one of the things, that sort of raises a red flag for me, right? They inside of globular star clusters, right, which are supposed to be these collections of thousands and thousands of old stars, right? These clusters are supposed to be, at least the age of the galaxy, right? So pretty old, right? Yet they find a bunch of hot blue stars, right? And the only explanation that is given is that these stars have merged together, right? And in so doing, they heat up and turn blue, right? But I don't think that anyone has actually ever observed that happening. And you would think that would happen relatively often. You've got these globular clusters of stars with hundreds of thousands of stars in them, all packed pretty tightly. Yet I don't think that we've ever observed any of these stars actually merge together. So what's going on there? I don't know.
I don't know. I read something in a book one time when we're moving closer to the Andromedan galaxy, the Milky Way, moving closer to Andromeda. They were saying that once they collided, it's going to throw our sun away.
Yeah, I think at this point anything is possible, right? Because actually, I heard a story, maybe it was a couple of weeks ago, that was saying, well, maybe the Andromeda galaxy isn't moving as fast towards us as we think. So yeah, this is science, and part of the thing,
and nobody's going to be right all the time. No.
With science is that we really don't have a clue, right? We're trying, right? We're trying to understand all these things, right? I mean, it's not as if we're making up false information and all this. We're really trying really hard, but these are hard problems to solve, right? And so that's why I say, stay skeptical, stay extremely skeptical, right? And especially when any scientist says we are sure this is done, we know this for absolute sure. That to me is a huge red flag, right? It's like run away from that. Because we can't possibly be sure about anything. We don't know enough, and we don't know what we don't know, and that is a huge gap. So yeah, I mean, I'm sort of exaggerating here, but 1 week, the Andromeda galaxy is rushing towards us, going to slam into us, right? And then the next week, it's like, oh no, actually, it's really rushing away from us, and something else is going to run into us, right? So the story changes all the time, and that's okay, right? We're trying, but just don't rest too hard on anything, because we just don't know. We just absolutely don't know at all. So, but as far as I'm concerned, that's what makes a lot of this extremely interesting, right?
What does Carl Sagan means in episode 9 of Cosmos that one day we're going to see a galaxy rise, not a sunrise?
Yeah, you know, he talks about a galaxy rise, and I think that is speaking in terms of space travel, right? Actually being able to position yourself relative to our galaxy such that we can be, you know, sitting on some planet somewhere, um, and you know, as the planet rotates, right, instead of seeing a sunrise, we would see a galaxy rise. That's entirely conceivable, right? But I think he was talking in terms of space travel, right? I don't remember. I'm gonna quickly reach up to my collection of Cosmos and see which episode that was.
It was episode 9.
Episode 9, The Lives of the Stars. Yeah. I think he was talking in terms of space travel there, as I recall. So I would have to watch it to exactly remember, but yeah.
I love rewatching Cosmos again.
What's that?
I really love watching the original Cosmos again.
Oh yeah, absolutely. Well, you know, it's continuously on Twitch. There's a Cosmos channel on Twitch, and you can go there anytime, and they have it playing. So definitely get over there if you can, and give it a watch whenever you want. Right? It's always on. It's always on. You know, they just cycle through. All right. Well, let's take a quick look at Delta Leo here. Obviously, again, a whole bunch of names, right? A whole bunch of names. Obviously in the constellation of Leo, so we don't have to worry too much about where that is in the sky. We already know. Pretty well studied, right? 261 references. That's pretty good. Let's see. Well, this says that it's got a distance measurement and a diameter measurement and all that. Let's take a look and see here what they've got. So about 18 parsecs distance. Let's see, what is this here? Oh, I can hear him in the background there, Bobby.
Oh, yes, it is. And I just slapped on the follow, and bam, bam.
Good for you. Good for you. I'm glad you found it. So there are...
Thank you.
Yeah, no problem. So there are 3.26 light years in a parsec. So 3.26 times 17.693 is about 57.7 light years away. So pretty darn close, right? Pretty close. So this looks like an angular diameter, right? Because it's in milliarc seconds. So 1.18 milliarc seconds. That's what this MAS means. So that's a very, very small angle. So pretty cool. Pretty cool. It looks like the radial velocity measurements have actually been pretty consistent over consistent over the years. Excuse me, even going back to 1892, it looks like, you know, even they measured it moving towards us. Now, you know, there is some inconsistency here. So is it inconsistent because the actual velocity of this star has changed? Or is it that, you know, our measurements have have changed or improved or what, right? I mean, do you trust the more modern ones as opposed to the older ones? Or is there an actual velocity change there? That's actually one of the questions that I don't think you hear very much, right? You hear a lot about how the stars are moving, right? But are they slowing down? Are they accelerating? That's a harder question to ask, right? Because it takes time, to measure all these things. So, and that's actually one of the things I'm relatively interested in getting into, is actually looking at the motions of these stars and seeing if their motions are changing over time. It's kind of an interesting question that I don't really hear a lot of people asking. So, and maybe I'm just not looking in the right place. Who knows, right? Proper motion. Here's some temperatures, right? So they've attempted to measure the temperature of these stars, and that's pretty consistent, right? Around 8,000, probably Kelvin. Pretty good. It looks like the spectral type hasn't really changed over the years either, right? Even back to what's the earliest one here? 1949 or so.
Good night, Otto. Sleep well.
Yep. Thanks for coming in, Atta. Sounds like you're having a great time over there. So keep it up. You're doing great. Yeah.
Hope it's better than showbiz, that's for sure.
Well, you know what? She seems to have a great time no matter what she's doing. So yeah. Good on her for sure. All right, well, cool. Let's take a quick look at all the references. Let's see what's new and what's old. Evolution of the magnetic field of Betelgeuse. Wow, that's kind of cool. Not quite sure why this paper is referenced in this object, but okay. It's kind of interesting. I wonder how they're measuring the magnetic field. Don't know. Leech exoplanet imaging survey. Everybody's hyperventilating over exoplanets. So yeah, that's all right. That's all right. Somebody has to. Let's look way in the past here. This is really nice because it's temporally ordered, right? So we can go all the way back to when these stars were first observed, and some of these I recognize, right? The Potsdam observations, we've looked at that paper before. I think we've looked at this one too. Observed at the Cape, which is the Cape of Good Hope. Interferometer observations of double stars. That's kind of cool. I wonder if this is a radio interferometer. I don't think they were doing radio interferometry in 1922. So, wow, some kind of interferometer, optical interferometer? I didn't know that they were doing any kind. Yeah, I didn't know that they were doing any kind of interferometry way back then. That's almost 100 years ago. Wow. Let's see here.
Paul W. That's for sure.
Paul W. Merrill. Yeah, a nice long paper. So they're looking at double stars, combining the previously reported measurements slightly corrected with observations made on 10 nights.
How many of those interferometers are we looking at like from the time that he did that paper to the time now?
Well,
If there was ever was a such thing as an interferometer in 1920, just like you mentioned.
Yeah, I'm trying to understand what they're even talking about still. So they're talking about some kind of a instrument attached to the 100-inch telescope, but I'm not quite sure what they're talking about here. So let's find out. Interference fringes.
Don't go too fast.
Measure of distance on 5 nights. Well, the positions were known to be decreasing at a rate in keeping with a revolution period of 104 days. A double star orbit was computed by him using the spectroscopic elements previously determined at the Lick Observatory. Okay. But so the present paper is a record of further applications of the rotating type of interferometer to known double stars and to a search for new doubles of small angular separation. Wow, I'm not quite sure what they're talking about. Huh. Constants of the interferometer were redetermined independently. Not quite sure what kind of interferometry he's talking about here, but obviously he's making measurements of binary stars.
Maybe there is such thing as an interferometer in the 20s.
Yeah, I'm just not quite sure what kind they're talking about. There's all kinds of
but in your recent,
interferometers.
if you can recall the most earliest interferometering projects that you have, what's the earliest you can think of?
Oh, I don't know. Yeah. Again, I mean, it sort of depends on what kind of what kind you're talking about. I think what they're talking about is actually using the fact that there is a binary system and using the interference pattern between those two. I'd like to see some pictures. I wonder if they have any pictures. Trial show.
I just like to see an old Morse code decoding machine. Or some kind of hardware decoding machine they had during the World War II era and stuff.
Huh. Yeah, that'd be cool also. I want to see some pictures if they have any here. And I'm noticing what time it is too, so I don't want to harp on this too long. Examination of stars for duplicity. A number of stars have been tested for evidence of duplicity by looking for variations in the visibility of the fringes. Yeah, so they're looking for interference fringes between two stars, right? So yeah, that's kind of clever. Kind of clever.
Table? Maybe,
yeah.
Maybe that will help.
Well, that looks just like a table of measurements and whatnot. Still looking for, and in fact, if I'm understanding this right, actually poor seeing, bad seeing actually helps in this, because you get more interference with bad seeing. But I'm not seeing any pictures though. So yeah, kind of interesting. Might have to investigate this a little bit more. But well, I guess the one thing that we didn't do in this paper, and that we should, is actually look for Delta Leo. Let's do this.
I was looking for it.
Okay, yeah. In fact, I wasn't looking all that hard for it. So there's Epsilon Leo, there's Eta Leo, there's Alpha Leo, there's Zeta Leo, Rho, there's Delta. So, okay, so this is a table that says stars apparently single. All right, so here's Delta Leo, and they give a, well, they give a right ascension. I'm not quite sure why he doesn't give a declination. That's a little weird. But let's keep going here. Let's just see if there's any other mention of Delta Leo. Well, it doesn't look like it. Kind of scrolled through that kind of fast. Omicron Leonis. 10 Leo Minor. Yeah, no. So obviously the star.
Okay, so Chuck Nichols got some type of disembarkation of what technology to use. 1920s combines light from two or more mirrors pointed at the same star.
Very cool.
So I think that's like some form of interferometer.
Yeah, because that would form some kind of an interference pattern, and if definitely if it's a single star, you would have one kind of pattern, and if it's a binary star or some kind of multiple star, you'd have a different kind of pattern. So cool. Yeah, nice.
Who uses an interferometer today? That's what I want to know.
Well, interferometry is sort of evolved a little bit, and as far as I know, it's not really used that way anymore. But lots of interferometry is done for like the high resolution stuff. Radio telescopes use lots of interferometry, right? So yeah, I mean, it's still used today, just sort of not in the way that this is being used. That's kind of cool, though. Anyway, so yeah, the only reason why this object is here at all is because it was determined to be a single star, right? Not a binary star. Wow. All right. Well, I think for now, let's get on out of here. I noticed that it's 23 minutes past 3 UTC, so a little bit past time. I think it's about time to get on out of here for today. There is always tomorrow, at least that has been my experience. Is that
just like
tomorrow,
Annie, you're always a day away.
Always a day away. Tomorrow is always a day away. So yeah. So yeah.
I didn't see the original Annie. I didn't see the newer one and stuff.
Okay, yeah. I don't know if I've ever seen any of them. But regardless, I think I'm going to get out of here for now. So thanks everybody for coming in. Make sure to subscribe if you haven't already. Hit the bell to be notified. You can hit the thumbs up if you so desire. You can make some comments. Spread the word. Always like to have new people coming in. I also definitely like to see all the regulars. And yeah, feel free to come in anytime, right? You can come in every single day if you like, every week, every month, whatever you like. We're, my thing is to be here as often as I can. Same time, same place, 2 hours UTC. And yeah, I at least for the foreseeable future, I don't think I have any plans on, canceling any live streams or anything. Are going to be starting to have some clear nights here. I sort of have to decide what I'm going to be doing with all of that. So, you know, some of the live streams might be outside doing an obs session. Yeah, so every single day, same time, same place. All right, everybody, take care. Peace, cheers, and all that. And I will see you in about 22 and a half hours. All right. Live long and prosper.
Live long and prosper. See you later.
All right. See y'all later. Bye.